Welcome to Brain Vision.
We start by calculating the integral from minus L over 4 to L over 4 of cosine squared 2 pi x over L dx equal to 1, so we can get A. And we're going to scroll down a bit to make some room. So we want this integral, first of all. This is equal to x over 2 plus L over 8 pi sine 4 pi x over L evaluated from minus L over 4 to L over 4. A lot of times I get these types of integrals from tables, but you can also use tricks like integration by parts to evaluate these integrals. But for the purposes of these videos, it's more convenient to just write the integral down as a result. So proceeding, we go ahead and we evaluate at the endpoints, and we have a squared 1/2 L over 4 minus negative L over 4. And then we look at the sine function. We notice we have 4 pi times x. If I substitute L over 4 or minus L over 4, either way, there's not supposed to be that stray mark there. So that was meant to be L over 4 to indicate that if we were to place that in x and multiply 4 pi times L over 4 and divide by L, I would simply have pi. So you would end up with sine of pi or sine of minus pi. Either way, you would have 0. So we get no contribution from sine from either of these terms at the endpoints. So we have 0 minus 0. And we're left with only these contributions from L over 4 and negative L over 4. These two minus signs, by the way, will multiply to give us a positive sign. So we now have L over 2 because L over 4 plus L over 4 gives us L over 2. We are multiplying by 1/2, so we now have L over 4 once again. So this equals a squared times L over 4 equaling 1. And scrolling down one more time, we get a squared equals 4 over L. We simply multiply both sides here by 4 over L, and this gives us a squared equals 4 over L. And we take the square root, and this gives us a equals 2 over the square root of L. So the normalized wave function becomes psi of x equals 2 over the square root of L cosine of 2 pi x over L. And we'll use this for our next part. So we're going to get a probability P is now equal to 2 over square root of L squared. And we're looking at a probability over the interval from 0 to L over 8. And we have cosine squared 2 pi x over L dx. And this gives us 4 over L times x over 2 plus L over 8 pi sine of 4 pi x over L evaluated from 0 at 0 and also at L over 8. So looking at the sine function, if we evaluate at L over 8, we can possibly get a contribution. But if we evaluate sine at 0, we will not, because the sine of 0 is 0. So let's scroll and get some room here, and we have the probability equals 4 over L, and we've got 1/2 times L over 8. The 0 will not contribute for x over 2, so we don't have to look at that. We have L over 8 pi times the sine evaluated at L over 8, so that is 4 pi over L times L over 8. These L's will cancel, and yes, this will be pi over 2, so that's the sine of pi over 2, which is 1. So now we have 4 over L times this 4 over L times 1/16, or L over 16. This gives us 1/4. Let me write this a bit lower. So we have 1/16 as our first term here, plus we have an L right here over 8 pi times 4 over L, and that gives us 1 over 2 pi because the L's cancel, and we have sine of pi over 2, but that's 1. This is 1. So our final result is 1/16, 1/4, I mean, plus 1 over 2 pi. And that, if you evaluate it as a decimal, is 0.409.